DOEs are most powerful and efficient when used in a series. Remember, DOEs are a tool to find and follow a path of gaining knowledge. And since product development is an exercise in gaining knowledge, DOEs are an exceptionally valuable tool in innovative product development. What might a series of DOEs look like? What is it that I am talking about here? You know, there's any number of paths again, but here's an example. Say you're on a team developing an alternative to a typical computer mouse. You've landed on a design that's just a bracelet. It's just sitting there and you get to play with it. Now, it's got a couple dozen sensors in it, your design does, and they're sensors of different types. The team doesn't have a firm grasp on how the form factor and the material composition impact the performance of the stress sensors that are in there. There are others as well, but the stress sensors are being a bit problematic. So they start with a highly efficient screening DOE, including 8 different factors. You know, they don't want to waste time and sample size trying to model the entire relationship yet, aka determine a transfer function. They're just trying to determine what are like the actually true impactful factors. From that DOE, that screening DOE, they learn that a couple of dimensions and a couple of material properties clearly impact the performance of the stress factors. So the team decides to run another DOE to get a decent model of how those factors, those 4 factors, impact the performance. They include the 4 impactful factors and narrow the test range on them because they can bring those levels in a bit. And then from that second DOE, they've got a good mathematical model of the stress sensor performance. And again, how those factors impact that stress sensor performance. They've also learned that one of the dimensions and the compression modulus are really the 2 dominant factors out of those 4. So the team sets aside the other 2 factors, the non-dominant ones, at easy to achieve levels. You know, maybe for cost purposes or ease of manufacturing or whatever. They're still within that range that they tested, but they can just set them to be. And then the team runs a third DOE to optimize the 2 dominant factors for the sensor performance, right? They get a great surface response graph that will allow them to optimize the final design parameters. They're not quite done yet because this is, you know, a best practices sort of team. So lastly, they run a robust design DOE pair. The first is a noise DOE and then a co-optimization DOE. In the end, the team has an optimized design that's robust against user variability, environmental conditions, and all sorts of other noise factors. That's what it's like to run a series of DOEs and what it might look like. And you don't just get there with a single DOE. And you sure as, insert your own favorite expletive here, aren't going to get anywhere near that with 1 factor at a time experiments.